So I'm going to talk a lot about some of the issues that I'm sure you're hearing a lot about with the new data science field emerging, so to speak. Not that a lot of the things that are being done are very new, but there's definitely a greater emphasis on data analytics and so on. One of the things people often confuse about is how does it relate to simulation models, operational research, and some of those other methods, and what is the best way of combining those techniques ultimately, again, to create value for the business. So that's what's going to be the topic of my presentation. So real quickly, who we are. So I know most people probably don't know what USAA is, but it's essentially a financial services company focused on providing financial security to our members who are military service personnel. And we are very heavily focused on serving these customers who we call members. So if you don't know about USAA, you may want to check out, on the web, and you will be surprised to find out about us. How focused on customer service we are. We are typically top ranking in many of the customer service surveys. We go head to head with people like Amazon and so on. And the interesting thing is that we are a bank. So you can imagine how much our customers love us. Okay, so these are the topics I'm going to talk about. How does what we do generate business value through prescriptive models? I'll talk about a decision framework that we use at USAA, and I'll talk about some case studies, and then what kind of business results we have been seeing. Okay, so for the kind of work we do, business value gets generated only if a decision gets made through the use of these models, right? So say, okay, so what kind of decisions? So this is kind of a shopping list of the kind of decisions we are talking about. It could be investment analysis. Hey, what are my options? Where can I invest money? Right? When should I invest? How much? Right? I have all these different things where I can put money in. What are the different ways I can do that? Right? So if I can help make that decision possible for my business partners, then business value has been created. Okay? Similarly, stress testing. Under what conditions will my system come under stress? And there are what-if analysis, and we saw lots of examples of what-if analysis, throughout the days. What happens if I do this? What happens if I do something else? Operational readiness. We did a lot of that in DoD space. What are the things I need to do to be ready for unexpected events? Right? And optimization, of course. What are the best possible settings to produce the most benefit? Now, to do all of this requires what we call nowadays prescriptive models, right? So these go beyond the normal statistical models that many people use in the data science community. So from statistical regression models or data mining approaches or machine learning approaches don't quite get you to be able to answer these questions directly on their own. Right? So that's where another set of tools and methodologies comes into play that make some of those models into prescriptive models. So from my perspective, a prescriptive model should combine known system facts, structure, and process. Right? So these things have to be taken into account, and you can begin to see right there a lot of the simulation modeling techniques that you guys are all very familiar with come into play. Facts derived from data and statistical analysis. So that's typically the focus of much of data science, isn't that bullet number 2. So it is a key component of what you're trying to do. The third aspect is the causal hypotheses or business judgment and assumptions that business people know about. Because as I'm sure you have all seen that when you go trying to collect data, you will never get all the data you want, right? A lot of the data you really need to model out is missing. Well, that's where business assumptions comes into play, right? Either it's expert knowledge or experience that can be coded as assumptions into the model, and we can play with it, right? And see what is the impact of those assumptions on the outcomes. And then the dynamics of the system itself. So if you combine all these pieces together, that's when you get a prescriptive model that can be used to answer those business questions we were talking about. And this tells you not only how the system will behave, kind of the predictive modeling side of things, but also what are the actions you can take. You know, what are the outcomes you should expect out of it, and where the assumptions might be wrong, right? As we build models, we often find that when we put in a certain assumption, very crazy things happen in the model. Well, that should be a pointer to say, okay, maybe the assumption is bad, right? Maybe I need to fine-tune that assumption, for example. And you can explore a wide range of scenarios. And I really like this quote from Paul Saffo, and he wrote in a HBR article in 2007, so almost 8 years or so ago. And I think he said it best, that the goal of forecasting is not to predict the future. That's not the point, although that's how people many times look at it. He says the goal of forecasting is to help you make good decisions today. You know, what do you need to do today is the objective. So that's what the models and the simulations should be focused on. Not necessarily to predict exactly what the value of X will be, 3 months from now or 3 years from now. So using that kind of a approach, I find that it's much better to engage with my business partners at that level, right? Because people sometimes get hung up on, how good is the prediction from your model? I said, don't worry about that. You have a decision to make right now. And that's what I'm going to help you with. Not predict what's going to happen 3 years from now. If that happens to be true, that's just good luck, I guess. So what are the methods? Well, we all know the methods. I think in this audience, I don't need to tell you about the multi-method modeling and so on. So this slide is really for other audiences, but just for completeness sake, so we have the discrete event simulations, system dynamic simulations, agent-based simulations, and combination of all of the above, right? And that was really the powerful mechanism that I've been trying to exploit for many, many years now. Okay, so what does a decision framework look like for our organization? So what we typically try to do is to focus on kind of 3 endpoints. And the 3 endpoints are, what are the outcomes that you want to achieve, right? What do they look like? So for example, one outcome could be better profitability, right? Or for a company like us, customer satisfaction is a huge important variable that we focus on a lot, and quality and so on. On the other side, you have things that are under your control. So these are your decisions. What are the levers you can pull, right? We want to get an understanding of that. And the third is, what are the external factors that are not in your control, but they affect your system's behavior, right? So once you understand those 3 pieces, now you're ready to kind of fill in the blanks in the middle. It could be a system dynamics model, could be a discrete event model, could be an agent-based model that comes in between to convert those factors into the outcomes, right? And then you can start playing those games. The piece in the middle essentially is a collection of cause and effect variables that put together creates a systemic understanding that I call insights, right? So there's a lot of people in the data science community talk about generating insights. Most of the time, the insights that people talk about take the form of oh, 30% of my customers have this characteristic, right? 25% wear a red hat, or whatever, right? So these are the kind of insights people generally talk about. To me, that's not really the insight. Once you understand a cause and effect relationship and a combination of those, that truly is the insight. And then if you can make it actionable by tying it to the things you can do, that's when you have really something powerful. So in the data science community now, that's the thing we are after. How do we create these actionable insights that our business leaders can use to understand what decisions they can make, and then what are the implications of those decisions? And you all have seen system dynamics models. So I'll quickly zoom through, how do different factors might be affecting different parts of a process or agents and so on. So once we have this map completed, it basically tells us systemically how different pieces work together to create the outcomes that we are trying to achieve, right? And at USAA, that's kind of the direction we are going. So I can't show you the actual real model there, but I think you get the idea of what we are trying to do. Okay. So once you have that entire picture, now you really have a strategic tool in your hands where you can now say, what are my strategic choices? What are the risks? What are my operational processes? How are they tied to my strategy? What are the causal hypotheses, and what is the value I'm generating? Not only for the business, but also for the customers, right? And now you can tie that strategy to the operations of your business and create the alignment between those things. Once you're able to tell a story like that, it's very difficult for somebody to argue that what you did not add value, right? And that's a problem you always, run into in data analytics kind of space, that, you build a model, you show them something, they say, I'm not sure the value was generated. And that's typically because you were not able to do an end-to-end view like that, showing all the way from decision to the actual value that a business cares about, right? And that outcome typically is in those terms of profitability, customer satisfaction, quality, and things of that nature. Okay, so some case studies. So the first one I'm going to talk about is our contact center management. So USAA is very big in customer service, so we actually manage a lot of our own contact centers. So in the contact centers or the call centers, the key issue is how do you optimize the headcount, skills that the customer representatives have, and how do you schedule them, and how do you route calls to the people who are going to be taking those calls, right? So how do you optimize that entire ecosystem? That's really the key problem. And the reason you're trying to do this optimization is to improve, again, customer satisfaction, improve the utilization of your call center, and lower abandonment rates. Because if people have to wait long, they will abandon, and that's not good for anybody, right? The customer went unhappy, and you lost the sale or opportunity to service that customer. And we wanted to provide a lot of what-if analysis capability to our business partners so they can optimize these things. So now you may say, hey, call centers, why are people still looking at call centers? There are plenty of models out there, including demo models in AnyLogic that you can use, Well, it turns out that a lot of the approaches people are using right now have deficiencies in them. And that's partly because of the complexity of our calls. So we have very large call centers and, in a highly complex environment. So the issues we start running into was kind of granularity. So what is the lowest level of time increment that you're modeling at, right? That can make a huge difference. Different skills and different skill groups. right? So if you have a call center where people have 2 to 3 skills and 3 to 5 groups, that's fine. But if you have hundreds of skills and hundreds of groups of people with different kind of skill combinations, taking hundreds of different types of calls, suddenly you can imagine that the complexity explosion that happens, with that kind of a scenario. There are also missing effects many times. For example, abandonments, multi-skilling of the customer reps, right? So the customer reps don't have just one skill; they can have multiple skills. And the routing logic itself, right? So most models assume a very simplistic routing strategy. But many of the switches, like if you use Cisco or Avaya, they have their own way of, a very specific way of how the calls get routed. And that has to be taken into account for an efficient way of simulating. And the attributes of the customers as well as the service representatives and the individual agent behavior. So these are all the complicated factors that actually make call center simulation much more difficult than people typically realize. And that leads to inefficiency, right? So obviously a lot of people operate call centers, and there's still a lot of inefficiency in that environment. So basically we have built a fairly detailed representation of the calls, the sales reps and their skills, the routing and abandonments. And we have been now using that for over 2 years now in our environment to achieve fairly interesting and dramatic results. So for example, you can see there's a customer service index that we measure, and you can see that we were able to optimize that, including optimization of abandonments, meaning we were able to reduce abandonments significantly. And this is without adding additional headcount. Okay? So a lot of this is now in actual use, and we are continually refining these models to the point that we're pretty soon going to be able to model the entire call center ecosystem. So the call centers we have still are separated into multiple call centers, our own and third party and so on. We're trying to put together a holistic environment where we'll be simulating all of that in one shot. So that's kind of where we're headed. Okay, so number 2, I'm going to talk about another key decision problem that I'm sure every company runs into is how do you prioritize your investment roadmap, right? So you have, let's say on a yearly basis, or depending on every company, they want to know how to invest for the next year, right? Whether you do it on a 6-month cycle, 1-year cycle, and so on, that's always a big challenge of, how do you manage that portfolio? So we put together a model, and this is just a high-level representation I'm showing you here that shows the investment figures on the left, right? So these are all the new capabilities or new projects that you're trying to do, interdependencies between them, how much is it going to cost, what kind of benefits it's going to produce, and what is the risk associated with each one of those, right? So we were able to put together a model where we can optimize across all of these dimensions to look at what is the best possible roadmap given the amount of money you want to invest, okay? And taking dependencies into account. Now, dependencies is probably the trickiest point in all of this. There's a lot of portfolio optimization that happens where people don't take dependencies into account, right? And it's really those dependencies that typically come and bite you, right? So anyway, so we can set up an environment like that. We then create multiple portfolios using this approach, and then we can actually simulate the operations of the company with these investments in place and see what are the long-term implications of making this investment, right? So you saw there's a high-level view of what the benefits expected are, but we don't just stop there. We can actually run a very detailed simulation behind the scenes, over a 12, 15-year period, and had to blur out a lot of the data. So, yeah, you're still seeing correctly. You don't need new eyeglasses, but you can see we can, for any given portfolio, we can look at what are the expenses and the revenue and profitability of the company looks like, what is the impact of customer satisfaction, which key resource groups are going to be under stress. So you can see those, red, yellow, green little circles on the left bottom side. That shows are there resources in the company that's going to be under stress given this kind of an investment roadmap, right? So it means that I probably did not invest in the right places to alleviate their burden, right? So since I see a lot of red there. So I'm growing too fast and people are not being able to keep up. Right? So we can actually run now multiple roadmaps through that process and look at what is the implication of that roadmap on the overall profitability of the company, in all of those cases over a N-year period, right? And that's when we can then select which roadmap or the investment roadmap we want to select and go forward with it. Okay? So that's just, another example of how we are using the simulation tools and AnyLogic tools combined with data analytics to solve the problems. So anyway, so I can't give you actual numbers, but there's definitely quantification that we do for many of these projects, and we have seen increased revenue due to reduced abandonments for the call center side, improved customer satisfaction and wait times, reduction in hiring and training costs, for example. We were able to find what is the best mechanism to train people and what skills they should be given on the call center side. A lot of risk reduction based on the portfolio analysis I just showed you, and also the investment prioritization. So now we can invest in the right things, not only things that just look attractive, but we know exactly what the operational impact of those investments is going to be on the business. So in summary, then the key takeaway is always take a systems view. In data science, data analytics, typically it can be easy to be seduced by a lot of data and take a very narrow viewpoint of something. So there are a lot of people analyzing web traffic and coming up with conclusions based on that. But doing that could be dangerous, right? If you don't understand the overall system implications of what you're doing. Explicitly tie key decisions and outcomes to your operating processes, right? It can be done through system dynamics, could be done through agent-based modeling, and so on. You have a good toolbox in your hands. Include and incorporate data analytics as well as business judgment in your systems and in your models, right? Because many times the difference between a successful model is that whether you or not you took business judgment into account, right? Again, where data is not available, right? Data always comes first, but many times you have to layer in business judgment on top of it. One of the key things we are doing essentially is to expose assumptions. People have these long-held beliefs on how things work, right? And as we are building these models, we find that many times those things are not true. So part of what we do is exposing those assumptions that, okay, yeah, it's, yeah, you can try that, but doesn't always work, right? So for example, in the call center environment, we found many times adding more people actually made the performance go down. That was a big shock to many people when we said that. Then, okay, no, don't add too many people in that area because that'll just mess things up. And they just didn't want to believe it till we were actually able to show them why that was happening. So any single method based on what I have seen, is not sufficient. So that's why the multi-method modeling approach, combined with a lot of the data analytics and machine learning mechanisms, is what we are finding is giving us the best value. And you want to create these dynamic visualizations to allow decision makers to explore multiple options and scenarios. I've found that I'm more successful when I can give them multiple options rather than telling them the answer, right? Even if I know the answer, I will almost never tell the answer, right? It's okay, here are the 5 things you can do, and here are the pros and cons of those 5 things. Now you pick which path you want to take, right? And that always works much better than saying, okay, here is the best answer, or here's the optimal answer. So, but again, in the end, analytics and modeling and simulation adds value only if it informs a business decision, so that's what you need to be focused on. So that's all I had. Any questions?
The number of what-ifs people can do is really infinite. So have you thought about optimization as a way to guide them to only look at a subset of all the possible infinite variations they have? And I would have the same question for the barge application we saw this morning.
Yeah, so this is the approach that I have taken over the years. In the early days, when I built a simulation model, my first reaction was almost immediately to put optimization on it and find the best answer, right? And go running to people and say, hey, look, we found the best answer for you. Unfortunately, it almost never worked, right? Nobody ever accepted that answer, right? So scratching my head, what's going on here? Then I started taking a different approach. I will first give them ability to do what-if analysis themselves. And if there are, in fact, 1,000 possibilities or 1,000,000 possibilities, they will actually come running back to me and say, can you, we are tired of playing these games. Can you find me optimal? Say, yeah, I can help you with that, right? And I've found that approach works 100 times better than the previous approach I was taking. So I don't know if that answered your question, but that's the methodology I use.
So the question is, how would you guide, given the simulation model, how would you guide yourself in helping that second iteration? Would say, what is the space I should really be exploring before I venture?
Exactly, and that actually works nicely because you do want to explore that space yourself first to gain insight as to how is your system behaving, what is the system trying to do. And once you have gained that insight by exploring and what if, I think only then you are really ready to do an optimization experiment on top of it. And I find many times, I'll get a question, help me maximize A and B, right? I want to find the answer maximizing A and B. And you run, a lot of what ifs, and you find out that A and B are actually pulling in the opposite directions. So say you can't have both A and B, right? What are you willing to give up, right? So it becomes a multi-objective optimization problem very quickly. But that insight itself is very valuable to them, right? That say, we thought we can have both A and B. Say, no, unfortunately you can't. Can't have both A and B. You have to pick one, right? So, and then you help them find that balance point, how much of B they are willing to give up to get the A, right? And so on.
Thank you for your presentation. I liked it. I like what you said earlier on about forecasting. So for the abandonment that was reduced and the MSI that was reduced, you had about 4 factors that you were looking at for that. And what was the cause and effect insight, I guess? What was the insight that you realized for that relationship to reduce abandonment? And what was the insight you realized for your risk management? And for the risk management, that might help my stock portfolio as well, so I'm listening.
So for the call center side, the key insight we found was that, and this is probably true for most call centers, that if you have multiple customer service representatives with different skills, right? The call volume that is coming to them is, has a lot of uncertainty associated with it, right? So you want to balance the load. But the load cannot be balanced if I can only take call of skill type A, right? So normally what people do is they start multi-skilling people, right? Oh, I should take this group and also give them skill number 2, right? And that improves performance. So, great. Next time, when you run into trouble, you do the same thing again, right? So you keep adding skills to people. What happens is, though, there is a diminishing returns. There comes a point where adding extra skills stops helping, right? But you keep spending your money on it because you learned a long time ago that that helped you, right? Well, the model, actually now we were able to find the optimal points, and we were able to tell them, okay, yeah, the optimal skill mix is this. If you skill more than this, you're basically wasting your money, right? And also causing problems downstream, right? Because in order to train people, you have to take them offline and send them to training, right? And all the time these people are getting trained, nobody's taking the calls, right? So you are getting hit both sides. So it was insights like that that we were able to find, that kind of went a little bit against the normal insight that people had learned over the years to overcome the problem.
So did you have to reconfigure the model so that agents or the critical, well, what was the critical component? Because I'm thinking that if you have a call center and you have agents in there that have, you have a model that you have agents with multiple skill levels or a range of skills versus another model where you have more individual or levels of skills where you kind of shunt the calls.
We built a more parametric model so we can play both of those scenarios in the same model. So we can give them additional skills, take away skills, and play a lot of what-if games and see which one works best.
So the critical situation was you had it was agent based, or was it discrete event that was you?
It's a mixed agent based and discrete.
Okay. Thank you very much.
You're welcome. All right. Thank you.